One more concept video involving Newton's third law. Pause, go ahead and reason out what you think the answer needs to be, and then watch the solution. All right, the correct answer here is A. The reason why, so it tells us this top block is accelerated across a frictionless table. So I know if I have two masses attached by a rope and I hang this guy over the edge, if there's no friction here, there's nothing to keep that box in place. So this system will immediately start to move. And not only is it moving, it's going to accelerate. The block on the table is going to accelerate to the right. The block that is hanging is going to accelerate downwards. Now remember, the acceleration of any object at all is determined by the net force it has, and then net force divided by mass. Since they're asking us to relate the tension in this rope to this mass, let's draw the free body diagram for that mass. We know the tension is pulling upwards. We know the force of gravity is pulling downwards. But we also know this system is going to accelerate such that the hanging mass will accelerate downwards. But again, it's the net force that is causing that. So if the acceleration is downwards, then the net force is down. The only two forces acting on that box, that hanging one, tension up, mg down, the only way to add those two forces vectors together to get the overall net force pointing down is if mg, the downward force, is bigger than tension, the upward force. So, bit of a thought process for sure. Our first inclination typically is wanting to say the tension equals mg, because in the picture we just see this mass hanging there. Keep in mind we also have to think through what the system will do. We have to think through acceleration. Will there be an acceleration? All right, one more conceptual question. The correct answer here is that block A accelerates faster in case B. So this is going to be a faster acceleration, bigger acceleration. So block A accelerates slower, so that makes C the correct answer. So in this case B situation, it's telling us the tension in the rope is 10 newtons. But in case A, we have this frictionless table again. There's tension in this rope. But again, if we think about the 10 Newton force, the weight of that hanging mass versus the tension, mg has to be bigger than tension because this system is going to accelerate downwards. That hanging mass will accelerate downwards. The box on the table will accelerate to the right. So tension in case A is going to be smaller than the tension in case B. With the smaller tension on the same box A, smaller tension will result in a smaller acceleration or a slower acceleration. So approaching problems, now that we have objects that are interacting with each other, it's a similar approach to what we've been doing, but now we have to see how the objects are interacting But we still have to think through the motion, the acceleration specifically to relate that to the forces.